What is the efficiency for hydrogen to power?
So the efficiency is about 1.5% over today's diesel engine. And people absolutely play on this efficiency of a fuel cell. So say our engine is, 41.5% efficient. People will say a fuel cell is 60% efficient. The fuel cell is when it's in a certain product with this constant output flow. When you put it into a transient response, when it's going backwards and forwards through battery systems, we end up being at mid-40s as an application. So in our industry, under transient response, we really struggle to get the efficiency levels that we would need. You also add in, remember the fuel cell, very high temperatures, very low temperatures. We need to control the temperature going into the fuel cell. There's a great university work done on products for temperature by a US university, well worth looking up. But you see the extremes, we either have to heat or cool, which again costs us those 5 big electric fans I talked about to get airflow, because it's 3 times the size of the existing fan that we put in today. So we have some real challenges. The other bit that we make a mistake, and I made this mistake many times in the early days. I obsess with numbers, efficiencies, and sometimes I just basically forget what's practical, what can practically work and what can't. So again, for our industry, we need practical solutions. Our machines rely on resale values. They move abroad, for a second or third life. Can you imagine replacing a fuel cell on a product that's 5 or 6, 7 years old, and it costs you £180,000 to redo that, to have a second life, when we could probably put a hydrogen engine in for £20,000 as a replacement unit to give it longevity. So there are lots and lots of challenges with work tools where, today, if you're digging a new railway line or you're digging something out, it's a cost per ton to move. Just imagine if all of the construction in the world was suddenly 5 to 10 times more to dig that earth out. You'd stop digging tunnels, and you'd stop digging motorways and railway lines and canals, because you probably just couldn't afford to put that infrastructure in place. So again, that's efficiency. One of the other great examples we have is we do electric forklifts, and we put them into distribution centres. But today, that distribution centre needed 50 forklifts to run across the shifts. They would buy 100. So they'd have 50 for a 12-hour shift. The other 50 would be on charge, and then they swap over. So those customers see electric products as being 50% efficient. So regardless of the technology we talk about, where the efficiency is very high, if those machines are standing, then it's 50%. They still use lead-acid batteries rather than lithium, for the simple reason, after 9 years, when they want to sell them on, it's much cheaper. The next customer will not buy that product unless you replace the batteries. So by using lead-acid, they can afford to have them on and sell a second life. So our industry is completely different from many of the applications. And, the work tool is a sophisticated shovel. It's just got to give that return. And it's our challenge to make sure that we've got affordable technologies that are practical, can be used for many years to come.